Okay, it's May 4th, and what is Project Blue? So Project Blue is a GUI uh, on that sits on top of FreeRTOS, and just like Windows 95 sat on top of DOS. So if we go full screen here, no, actually, you know what? Let us set up background, full screen, and this is running this windowing system. First of all, you wouldn't believe it, but it is actually framing at close to 20 frames per second, 640 by 480, 8 bits. Um, Go full screen, and you can see we can move windows around. Um, you can have all kinds of controls, buttons, and you can link those buttons to have those buttons do things. So let's say we want to add the text from here into the list box. Double click, and we've just added that text. And you can see how fluid the movement is, right? I mean, it's just really, really fast. You can resize things. Let's say we just want to do this and put this maybe up here. Let's say we want to get rid of this one, delete. Let's say we want to add some text, here. Add some text. Sorry, double click. And yeah, so what this allows you to do is instead of working with the ESP32S3 board purely in text from a console, now you can put um, intelligence in buttons and in controls and things like that. So it basically it is like Windows 95 in some ways, um, except without the blue screen of death. I've never, you know, seen this thing have a blue screen of death. But in any case, this is what Project Blue is. Get out of full screen mode. You can change the background to whatever you like. Let's say change background. So just to prove that we're actually doing the frame rate, let's go into the code. And let's go change the frame rate to, let's say 3 or something like that. And we're just gonna flash the board. It'll just take a moment. And sorry for the wait, guys. I should sped it up. It shouldn't take too long. So basically, from any device, any browser, you're able to log into your board and basically interact with it from a GUI's perspective. So for IoT, you can do timers. I'll show you that. You can have a web drive where you access files, unlimited amount of storage space um, on any, like from your desktop or the internet or anything like that. So you're not limited to an SD card. In fact, you don't need an SD card, but of course we'll put support in for that as well. Um, and I'll show you the working web drive. Okay, so we just rebooted, so the board just rebooted, yeah. So, yeah, we just rebooted, so everything went back. So, let's go, see it's a little choppy because you're running at 3 frames per second. So if you go down here, you can say we're really at a strict close to 3 frames per second. It's still okay. I mean, we could still do things, but I just wanted to show that we can get close to 30 frames per second at this resolution 640 by 480. Uh, we can still do things. So delete. I know it looks kind of antiquated, uh, but really, I mean, this is, you think about it, like VGA is very, it's taxing the CPU. Now we use compression to be able to do this, um, and that offloads a lot of. It basically reduces the amount of data you have to send over the network. So that's why we're able to get very high frame rates. But the quality, I mean, I'll show you, this is 640 by 480 by 8 bits, but we can go all the way up to 24 bits. I think 1024 by 728. But yeah, this is a real thing. This is being streamed by the board in real time. You know, it's a very, it's very real. So let's close that, close that. Let's resize that. Let's move that over here. Move that over here. Okay, that's it for the introduction to Project Blue, and let's move on. Okay, so I just flashed the board with the other thing, part two, I guess. So let's go to that. Let's take a look. So basically, these are the very, well, I didn't connect, so background image. Okay. These are the very early days, like, like it's just, I just started this project, so um, there's not a lot there right now. But I just wanted to show you, let's go full screen. This is streaming from the board. So the board is putting this image out of its frame buffer. So if we go to this drop down, of course we're going to make the controls really nice and sexy. But for now, let's say we want to make a label. We can make as many labels as we want. Change the text and everything, move it around. We can delete the components. So let's just make a label, put one over here, and then another label. So I just wanted to show you that, this is a real thing. And let's make a frame. A frame is, if you remember VB6, you basically put stuff on the frame and the controls are all together. So we're kind of aiming for that. I only started this project a couple days ago, so um, maybe less than a week or a week. So, and I don't have full time to put into it, so but I'm doing whatever I can. So let's delete the frame. Let's delete the label. Delete the label. And again, it's the ESP32S3, 8 megs flash, 8 megs PS RAM. And the PS RAM is critical, by the way. So let's do a text box. Hello. You can resize it, move it around and stuff like that. Let's create another component. Let's do another label. So we'll just have like a whole bunch of, actually, you know what? We'll move that over here. We'll move it over here. It's amazing how much, when you're in full screen mode, how much space you actually have on 640 by 480 if you do things right. We did text box. Let's do a checkbox. Put it over here. Show you that it actually does work. Let's do option button and option checkbox. Okay. Let's go. Let's go to a list box. Now this one is really kind of messed up. I have to fix this. It has a double. It has a double bar on the top. but yeah, in any case, it is a it is a list box. It's kind of strange looking list box. It's like deformed or something. But yeah, it's the easy fix. Put that one over here. We can close it as well. Oh, sorry, it's from the top. Do that list box again. Make it a little bigger. Put it here. So I have a whole bunch of controls on the screen. Combo box. So combo box we'll put here. And yeah, so obviously you're gonna make it nicer. This is my first pass at this. All right, and my tools are being messed with for some reason. Okay, so timer, timer here. Put a timer over here. Open it out. Close it. Timer again. You know what? Let's get weird and do two timers. Two timers. Oh, a two timer. Well, I don't think your girlfriend or your wife's gonna like that. Two timer? Not good. Not good. Okay. So we got a rectangle. Don't make it into a square. Keep it a rectangle. Move it around. Yeah. Don't be a two timer. Okay, and a circle. And of course, you'll be able to interact with this. This is just like very early days of this GUI for the ESP32. And the whole idea here is to have a rich set of controls and functions. And as we go to 16-bit and then 24-bit, the quality is going to be stunning. It's just going to be absolutely stunning. We don't want to be a two-timer, so let's delete that. We're an old timer. Okay. So why, like, what are some of the reasons, right? You would want to, oh, we're still stuck at 3 because I didn't put it back to 20. Why would you want to do this? Why would you want to have a GUI or like a graphical interface or a graphical OS for the ESP32? Let's take a couple. Let's talk about that. So there are, for the eye control and like what's the advantage over an LCD? Well, LCD has very good defined use cases. Um, if you're making a product or you're making something for automation or something where you need the touch screen and you need all that stuff, then that's fine. But there's some valid reasons for doing what I'm doing as well. And here are some of the advantages just off the top of my head real quick. You can view and interact from any device, anywhere, without needing to have the board with you. So you can have the board at your home, or wherever, your girlfriend's place or your two-timer place, I guess. And you can interact with it from anywhere in the world through the internet. So once it's connected, so you're not limited. With LCD, you have to be where the board is, right? Because it connects to the board. So you have to physically be by the board in order to use the LCD. This frees you away from that. You're not limited by the viewing screen size of the LCD. I noticed that you can't go past like 7-inch or something like that, for the S3, and that sucks. With this, you can pipe it to your big screen TV, HDMI TV, whatever, if it's smart, or your big screen computer screen or whatever. Have it as big as you want to interact with it. You don't have to buy an LCD, so you can save money. You don't need an SD card, but you can have it if needed because the GUI allows you to. This allows you to interact with WebDrive, and I'll introduce WebDrive in a minute. It expands the usability of the board to a wider user base. So, you can basically tap into the functions of the board through the GUI. So you can make buttons programmable. So that's why, if I go back to here, we have all these controls, right? So you can make the timer do things, link it to automated scripts and stuff. So you can do scripting on here. So instead of having to be a programmer, you can just double click a button and turn a LED on and off. You can, tap into the peripherals. You can do all sorts of stuff, and then you can make it give you visual feedback that it's working. Like a flashing button means that the light is flashing, so you can mimic the light and things like that. Give you visual feedback, but really make the programming like really easy on this, and be able to uh, have a wider audience like younger kids or people that weren't really interested in this sort of thing being able to do this sort of thing now, if they're interested in that. And for hobbyists that have been using this thing for a whole while, it's a new way to interact with the board, and perhaps maybe even squeeze something more out of it, like make games and things like that. We'll talk about that later on. But getting back to this, um, basically the whole idea is to make the using the board like super easy and fun, just the way Arduino kind of did, but without like text and without like a serial console, but like a fun, nice way to do it. It's easier to automate tasks and get things done without heavy programming skills. Have your IoT device interaction, non-text based, so beautiful UI controls without losing the power of automation and coding, because you can do that within the buttons, within the timers, within various things that we'll put in there. And it's easy and fast to use the board functions and all the peripherals. So you don't have to like load up Arduino and you know load up Arduino and get all that, or IDF or whatever. You can have a very slick, nice, beautiful um, uh, go-to interface to deal with the board, but still maintain that programmability, you know, uh, full programmability, right? So, and that's the whole idea of what I'm trying to do. What I'm trying to do here. So, yeah, that's the end for the second segment. Let's move on. Okay, so um, let's do like an application that actually works. And again, we're in the early days. This one's called WebDrive, and let's connect. And let's go full screen. So the whole no, hang on, let's make it a little bit smaller. First of all, just as a side note, this is compression is turned off and this is not optimized, so it's not like the other high-speed demo I just showed you guys. This was made like a day before that, so I haven't optimized the code yet, so it's like a little bit slower. Um, but in any case, it does work. It is an application running on ESP32 S3, and yeah, so let's go full screen. And let's say we want to connect to, I think it's a WebJS server to access some files from the internet. In this case, it's running locally on my computer. So if we do, let's go here. And so if we go IP config, my IP is like .39. So if we go full screen, oh, and to get this to work, I'm running node on port 80. And if we look at what's inside the directories, hang on. So there's a couple of files. File server. Right now, this is the contents of what's on my computer. These are just dummy files and things like that, but we'll take a look at that later. But you don't have to run node. You can connect to any shared drive or file servers or anything like that. So to use it, you would connect. and then it'll go out and it'll detect, the files in the directory, and you'll be able to do all the file copy functions. So it's like very super quick, easy way to get files from like your computer or from the internet directly to your SD card or to your flash partition on your drive. And it could be images, it could be music, it could be code, it could be whatever it is that you like, right? Um, let's disconnect. And what we're going to do now, just to test that this is a real thing, we're going to create some more files. So we're just going to paste some more files here. And it's not fully functional right now, but it's functional where it goes out and it actually finds the file. So if we connect now, you can see that it has all those extra files. So basically, yeah. So you have your, I haven't mapped the arrow keys, so I'm going to have to do that, but yeah. So I'm going to scroll this down so you can see all the files. Move this up here. Full screen again. Yeah. Well, so you can see basically all the files are there. This is just some garbage. I got to clean up the code. This was done yesterday. So with this, you're actually, this is real. Your board is going out. It goes to my computer right now. I got a Node.js program running on here. So if I quit this, start it again, it's a Node server, very basic, and it's serving up these files in directory. Let's delete WebDrive test file number 1, and those right there. Go back and let's disconnect. Let's clear. Let's connect. And you should see the test file number 1 is pretty much gone. And now let's go to here and just copy, paste a whole bunch of files, disconnect, connect, go full screen. And now you can see all the files, so it's a real thing. So why this app and what are the advantages? So basically, you have it allows you to have virtually unlimited storage using your computer or internet. Now you can do this in code in Arduino or IDF, but this gives you a very quick, easy way to do it, desktop style. You don't need an SD card, but you can have You can have an SD card and have full functionality. So list your SD card there as well, so you can use full file functions like read, write, delete, copy. You can basically drag and drop, select, right click on the files, get properties, like you do in Windows, like you basically do in a Windows environment, right? So go properties and it'll show you. So basically replicate that really beautiful usability now that you have a GUI to do that. We'll support little FAT32 and things like that on the SD card and on flash, so full control of your files, and you have full access to a remote drive, now your local drive and on your flash, but from that browser environment. It's zero programming, for partitioning and Windows-like functionality, and it gives you full control of your files. So the app just pretty much just makes sense. Now it looks kind of gross. Obviously, it was created yesterday, so it's and it's not optimized and stuff. So it's gonna, but it does work, um, and that's the kind of thing that we want to do with Project Blue is make things really easy to use for this for this board, so more people can see how wonderful it is. I hope you like this, and I know the colors are not great, but you know, um, hopefully, I could get this going to the point where it's seamless, just like Windows, and that's the whole idea. Make things easy to use. You can do a lot of things on your board really quick. You don't have to run programs and type in commands, and you'll still be able to do that. You don't lose that. And, I want to put a terminal here so you can still do all the things that you do, but instead of through the serial terminal in Arduino, uh, you basically, uh, we basically go here, right? And we do all of our work here. Well, instead of just having to do that, you have another option. So it just adds to your pool of options, which is really good. So well, I'm gonna resize it here. Does it? Yeah. Okay, good. So yeah, that's the kind of thing that. So it's the first truly functioning app um, that was built yesterday, and yeah, it's a real thing, and hopefully we can do some really funky stuff. Um, be able to go deep into the hardware, but from the GUI with, like I said, a console kind of thing. And let's disconnect here. Um, and clear. And I didn't put a close box for that yet, but you do have full screen mode. So click again. So all the apps should be able to um, go full screen. So connect. Yeah. So take up basically interact with each app in like a full screen mode, and that's the idea. So go back to desktop, move things around. Um, yeah, so that's the end of this segment, and I hope that kind of shows you that there's more to this board than meets the eye, right? So we can do a lot more with it. It's pretty amazing. It's untapped, and this is using Arduino. This is not using IDF. So once we can get into IDF, we can really really maximize the use of resources and get some amazing speeds and take full control. But for now, we're just doing it using Arduino code, and it's limiting in some ways, but it still allows you to do things really quickly. So okay, so we've talked about the app, and now obviously, if you're developing windowing GUI and things like this, that what we're doing Project Blue, um, we really care about the display and all the aspects of the display. So, for example, the color depth, the dimensions, and so on and so forth. And what's the best you can do, and like how can you push this, right? So, okay, so just just uploaded Sketcher. Let me just reset the board because we want to get all the metrics. Okay. Dot 37. Okay. So let's just pull up this. I've set it up as a web server. Okay. So let's go to yeah, pattern. Okay. So far I've been doing 640 6 oh god, my brain, it's 6 o'clock in the morning. I haven't slept all night. In any case, 640 by 480 at 8-bit resolution, so we can get that speed. I just want to show you here that this is, well, it's compressed, but we're doing, the board is generating an image in real time all the time, right? It's in a loop. And we're putting out 1024 by 768 24-bit, and it is sweet. Like the quality on that, right? Now, obviously, we're gonna go in full screen mode and be able to really utilize these, really utilize it, right? So you have a much more richer, crisper, high-end desktop. But for now, I'm just getting started. Let's see, memory stats. So we're able to, yeah. So we still have lots of memory to play with for PS RAM. And this is not optimized for speed, and there's no compression. So we're just blasting it over Wi-Fi, and it's pretty big. It's like it's taking up quite a bit. But I'm just telling you, like we can actually do 24-bit, 1024 by 768. Obviously, you can do 800 by 600 as well. So let's do something else. Let's show you that we're not eating up all, like we're not maxing out the CPU. We're not maxing out the CPU. We still have lots of cycles for applications and stuff like that. So let's go here. Let's flash the board. Sorry, I'm not speeding up the video here, so there's going to be a little delay for the code to get flashed to the board. But it's pretty amazing that, despite despite having RTOS there and then IDF on top of that, and then Arduino on top of that, you're able to basically output something like this through Wi-Fi, right? Because this is obviously it's a wireless desktop, so it's pretty extraordinary that we can tap it in like this. But if you really get into it and like optimize it and compress it and do some really funky stuff, then you can get a fairly decent working desktop. So this is all in. There we go. Okay, so we got a bunch of test pattern that the ESP32 S3 is putting out. And I'm not scaling down the image. This is the actual 1024 by 768 at 24 bits. So this pattern is random dots. And let's go to purling noise. Um, so, I mean, this is the actual 1024 by 768. So if you go full screen on that, I mean, it's just really crisp. It's near HD quality, obviously. And that resolution is near HD. And your ESP32S3 is putting that out. Um, obviously there's a few tricks that we're doing, but not much. And the whole idea is, it's nice to have the 640 by 480, right? That's really nice. It's working. It's good. We only started this project like very short time ago, so that's fine. But we'd really like to go to this. This is really like these images are being generated in real time by the board and streamed. Uh, so obviously it's taxing it a little bit. It's not taxing the CPU, it's taxing um, the the bandwidth for the Wi-Fi because it's a lot of data, and it's a lot of data. So it, that's why you have to optimize and you have to use compression, or else it'll be too much for the Wi-Fi. So it's mostly a Wi-Fi issue. When you do just the raw video like that at this kind of resolution near HD. Um, so you just have to bear with me a little bit here um, as we try to cycle through some of this stuff. And my Wi-Fi is not very good. It's it's like a dongle through the USB, so it's really slow. My computer itself is not very good. It's like an i5, you know, sixth generation. It's like super duper outdated. Anyways, finally caught up there. Now, if you look at this, right, you can see that it's not a static image. You can see the blends and the moving and things like that. So I just want to show you that this is being generated on the board in real time and streamed at 24-bit near HD quality, right? And this is just early level work without any kind of streamlining, without um, any kind of compression, which the other one is streamlined and compressed. So it's like super, super fast. But this is just to show you that it is possible to go to near HD, to have a near HD desktop on the ESP S3, 32S3. So, and the images are just stunning. Like you might not be able to pick it up from the video, but if you can go into put your computer to this mode, and it's basically full screen. It's incredible. I mean, we're talking some like a device the size of your thumb, and you can run it off like a little battery. So that's pretty amazing. I'm just gonna refresh this here. The board is still okay. Let's check what's happening. Oh, it's my internet is really crappy, so I'm just gonna reset the board here. Let's resetted the board. We just got an IP. Again, my memory stats. So I'm only using like 1 meg PS RAM. So let's stop this. Again, let's go to normalize. Yeah, there you go. That's it. Beautiful. I mean, if you look at the quality on this, like 24 bits, it's incredible. So I think we're doing okay, right? We're doing okay. This is just a test program. Yeah, doing okay. And I'm really sorry that it's really slow, guys. It hasn't been, you know, it hasn't been optimized, and then there's no compression, so it's like super slow. And my internet is just crap. My computer's crap, so I'm just doing whatever little we can. But you can see the blending and the bleeding, right? Like it's real time, so there's some. The algorithms are just doing it in real time using the Extensa CPU. Just take a little bit of catch up. I don't know. It's a little bit hypnotic. But you get the idea. I mean, all these patterns and colors and stuff is being generated in real time. Yeah. And it's not static. Like, it doesn't generate a static image. You can see the bleeding and the moving and the animation and stuff. So it's dynamic. Interesting color still. Yeah. I mean, yeah, I mean, you don't really need um, for an embedded board. You don't really need this kind of thing. Um, but it's nice to have high quality if you ever want to switch to that mode. Just to have some options. I'm just trying to push it right now to see how far I could take it, and I can't take it further than this. This is like the usable max. I mean, you can do some tricks and stuff, but this is supposed to be like a blue flame, um, a blue fire flame thing, gas stove, I guess. Um, but yeah, the whole idea is the whole idea is to just go into testing right now to see what we can do with it, and then this might be an option uh, for resolution, other than the 640 by 40, because with this you're able to put more windows and stuff on a desktop. Not that you might want to, but some people might. You might be able to have more of a workspace and things like that. Not that you'll need it, but you might, depending on what you want to do with this thing. So I just want to show you that. Is it plasma, right? Didn't catch. It's a little slow. Board is doing okay. It's still stable. Stable. Let's just refresh. Now let's reset the board. But yeah, I mean, just started this project. It's work in progress. I don't have a lot of time to give to it. There's a lot of other things to do, but hopefully we can get some cool stuff going here. just build it out. So I just wanted to show you guys that. Hopefully, uh, someone out there might find it interesting. Maybe most people will not, but and just to just to say that yeah, it's a streaming desktop, but it'll have a mode that but you can click that if you want to put the desktop, like have the desktop be on your LCD, like if you do have an LCD, um, it'll have a mode where it's not streaming, where it's gonna send it directly to the LCD. It's like super easy to do. So you'll have dual mode. You can either pipe it to your LCD, which you can just use it on there, interact with it that way, or uh, you know, um, or have it streaming, um, or both, right? So although I'm not quite sure if the CPU can handle that, but definitely at least one of them at a time. So just to have that option, I think is really nice. So yeah, just wanted to show you guys that the ESP32 S3 8 megs PSRAM 8 megs flash can actually do 24-bit at near HD. Um, it's pretty amazing. So hope you guys like that, and stay tuned. Have a great day, great night, whatever it is when you're watching this. Stay safe. Take care.